Hello everybody. Today we're going to talk about the long-term effect of irrigation with reclaimed wastewater on the Israeli citrus industry. My name is Eran and I'm from Gilat Research Station. So for the last 30 years, Israeli use reclaimed wastewater for agricultural irrigation. These days, about 86% of the irrigation water that we use are coming from effluent. And you can see that compared to other countries, we are quite use a lot of effluent water for irrigation. But there is some issues with this water. For the last 20 years that we were using this water for irrigation, this water contains a lot of salt. It's like adding 5 to 8 tons of salt per hectare per year to the soil. And this salt is not something good for the plant. Now, for the first 5 years of using such water, the government supported a survey that monitored the effect of this low quality water on agriculture, and they found no significant negative effect. So after 5 years, they stopped their survey. But what happened after these 5 years? This is a big question, and actually no one was monitoring what happened along the time after the first 5 years. It's not absolutely correct that nobody was monitoring, because the food process industry must label their food with how much sodium they got in their product, and they are monitoring every year how much sodium they got in their fresh product or processed food product. In this case, you can see orange juice bottles that in each one of them they are mentioned how much sodium they got in the juice. And I marked it with red squares. You can see 2 different companies. Both of them said that they've got 0 milligram sodium per 100 gram of juice in the product. It's not that they really got zero gram of sodium. What happened is that the law in Israel allowed them to write 0 as long as the volume of the sodium is below 5 milligram per 100 gram of fresh product. Everything was okay until one day I got a phone call from one of the juice company that complained that suddenly they got salt in the orange juice. They didn't know where it came from. They checked all the machinery and they couldn't find where this salt came from. And you can see, for example, this is another company that suddenly cannot write 0 sodium, 0 milligram of sodium. They suddenly write 5. And this was a big issue. And for me, it was quite clear that all this sodium that they found in the orange juice come from the irrigation water. But the big problem is how you prove it, how you prove that all this salt that they found in the juice are originally come from the irrigation water. Luckily, in Israel, farmers send leaf samples and soil samples every year to do mineral analysis. They do it in order to take decision regarding the future fertilization, future irrigation, how to treat their orchard. And what we've done, we create a big database that summarizes all the results that the farmers in Israel got during the years 1993 to 2012, which was about 30,000 rows of data, Excel data, which got all the mineral analysis of all the citrus orchards all around Israel. And we checked if there was any significant effect of the irrigation with the reclaimed wastewater on the citrus industry, if you can see anything that related to the salt. So let's start with some of the data. The first 2 figures are about the same, and I will explain what you see. So at the x-axis, you can see the years. And the y-axis is you can see the mineral concentration. In this case, is chloride concentration. And each dot represents an average of 100 to about 1,000 orchards that were sampled for chloride during this specific year. And you can see in 1992, before we start to use the reclaimed wastewater for irrigation, the chloride concentration in the leaves of the citrus trees from all the orchards in Israel contain about 0.2% dry weight of chloride, which is relatively low value and very good one. And along the years, this value increased and increased and increased till it reached the toxicity level, namely above 0.5% per milligram per gram dry weight. So this is what happened when you irrigated for so many years with low quality water. If we go to the next mineral, which is the sodium, it's about the same picture, but the value is a bit different because sodium, usually you got toxicity at lower levels. So if in 1994, 1995, the values was about 0.11% per dry weight of sodium in the leaves, along the years, the value was doubled and reached the toxicity level of 0.2%. This is a very dramatic increase, and this is a big problem because all the citrus orchards in Israel, this is the average, which means some of the orchards were far above it, some was below it, but in general, all the citrus orchards in Israel were under toxicity stage of salinity. Now, for me as a citrus guy, it was very important to see if it's only the problem of the citrus industry or this is something that is common for all the agriculture all over Israel. And the question is how can you check something like this? Because only the citrus people are sending leaf samples year after year after year, and it's very difficult to know what's going on with the rest of the agriculture in Israel. So what we've done, we took randomly collected about 650 fruits and vegetables from all over Israel and checked the level of sodium in these products, how much sodium we got in the carrot, in the banana, in the pears, in the lettuce, everything. And we see whether this value is high or low. Now, since each product got its own baseline, what we've done, we compare the values that we measured in each of the product, in each of the crops, to the USDA standard sodium values that publish in the internet. And based on this, we knew if our level is above the standards or below it. I'll give you a few examples. Here, for example, you can see 5 samples of avocado that we took from a different location in Israel. And the red line represents what is the 100%, which is the value that the FDA recommended and how much we are related to this value. So you can see that 4 out of these 5 source of samples, avocado samples, were 10 to 100% about the USDA recommended value, standard value, while only 1 sample were below it. I'll give you another example. Sorry. These are lemons from Israel. Lemons, we took 8 different samples of lemon from 8 different orchards. And you can see that all the 8 samples, all the orchards, were 10 to 100% above the USDA recommendation, which means all our lemons were far above the USDA standard for sodium. And here, for example, you can see all the crops from Israel, from pepper to eggplants, to apples, to grapes, everything. And you can see that more or less, all of our product in Israel got 10 to 100% more sodium in the edible part compared to the USDA standard, which means that we are under big salinity stress all over our agriculture. I was wondering regarding the lettuce, how come that the value was very low? And I asked where did they brought these samples, and they told me, oh, this lettuce came from farmer who used hydroponic to grow it, and it explained why the value was relatively low. But in general, more or less, all of our products are far above the USDA sodium standard that published in the internet. If we separate the different crops to annuals and perennial, we can see that in perennial crops, the problem are much bigger. And for me, it was quite clear because perennial crops accumulate the salt from 1 year to another, while in annual crops, every 3 months, you start a new cycles of life. So the effect will be a bit smaller. Now, everybody knows that salt is not good for human health. Usually high level of salt involved in high level of blood pressure. And you really don't want that the products that come from Israel will be characterized by high level of sodium. It's not good for the competition with the other growers around the world. And this is a big issue for the Israeli growers. And not only that, it's quite clear that soon we are not going to be able to continue to do any farming in Israel due to the high salinity level in our agriculture. So what can we do? This is a big question, what can we do? I'm not going to answer what can we do, but I will tell you that luckily in Israel, in 2008, we started desalination seawater process, That means that the water that came from that we use for drinking came from desalination process. What does it mean? You start with the water from the sea, you take the water and put them through membranes, and you come out with fresh water that have no, almost no minerals. Everything is very low, very close to distilled water. You can see that the magnesium level in the second row is 0. Sodium level is less than 30. The values are very, very low. That's what does it mean moving into desalinated seawater. And along the years, the amount of desalinated seawater that we use was increased. Till these days, it's about 80% of the water that we are drinking are coming from desalinated. You can see in these columns that the red bar, which represent effluent reservoir that got high level of salt, above 400 milligram per liter, was decreased along the years from 27% of the reservoirs in 2006 to 4% in 2016. How did it affect our orchard? So you can see that if you look at the chloride level in the orchard, suddenly decreased by 30%. This is a very good results. How does it affect the sodium level in the citrus orchard in Israel? It's also decreased by 30%. The problem is, and again, what happened with the rest of the crop in Israel? It's the same picture. Everything was decreased, and suddenly some of the crops got above the USDA recommendation, some below, but in average, we got the same value as the USDA recommendation. What about side effects? At the same time that we removed the salt, we also removed the magnesium from the water, and you can see what happened to the citrus Israeli orchard along the years, that the magnesium level decreased by 30%, and farmers invest much more money in buying fertilization that included also magnesium. And what about the rest of the product from Israel? How did the desalination process affect them? So again, we compared the magnesium level in all the fruits and crops from Israel, and you can see that in general, compared to the USDA standard, Israel crops contain 50% of the magnesium compared to the USDA standard, which is very bad. We can ignore it, but I can promise you that it's not good. It can cause some increase in heart disease, diabetes, all kinds of things. And even we reached the point that in one of the journals, they estimated that about 4,000 Israeli people are dying each year due to the lack of magnesium. Only few countries are monitoring the crop mineral nutrition, not all of them. And we need to remember that monitoring the crop mineral nutrition is crucial for sustainable agriculture and for our health. So what is the take-home message from this lecture? First, we need to recognize that our growth conditions are not stable. They are constantly changing. We got increase in salinity in water or decrease in the salinity in the water. We got climate change, increase in temperature, all kinds of things that what the growth condition that we used to have 10 years ago are not relevant for the current time. Some of the impact of these changes on the crop will be recognized only after several years. That means if we do some research for 2 years, 3 years, 4 years, 5 years, it might see that we won't find any impact of the difference in growth condition on our crop quality or crop health or crop productivity. But after 6 years, 7 to 10 years, suddenly some of the problem will appear. And it's very important for us to monitoring all the time. So if I'll summarize everything into one sentence, it's quite clear for me that continuous monitor of our crop mineral status, it's crucial for our sustainability and for our health. I would like to thank people who helped me with this data, Moti Peres from the north of Israel, Yasmin Luzon and Baruch Luzon, daughter and father that helped me collecting the fruits and analyze the data, with Raya Vulcan from Gilat Field Laboratory and Gilat Citrus Research Team. These are the people who work in my lab for helping me doing all this analysis. Thank you very much.